Hey guys, welcome to lesson 9.7. Today's lesson we're going to be talking about direct variations. Now, direct variation is a different type of slope-intercept form, and the biggest difference is that we are actually not going to have a y-intercept. Well, we technically will, but our y-intercept is 0, and so we're not going to have it in our formula. The form for direct variation is y equals kx, where k represents the constant of the variation. Now, it's said that x and y are directly proportional, which that is one of the definitions that are in your book. We just didn't write it down. But x and y are directly proportional if whatever we're multiplying x by will get us y for the entire set of points. Let's do a couple of examples and hopefully that will clear some things up. All right, example 1 is something like this. It's asking us, does y vary directly with x? If so, what is the constant and what is the equation for the direct variation? And then it gives us this table of different points where x is 1, y is 3, so on and so forth. Okay, so what we have to do first is we first have to figure out if y varies directly with x. Because if it doesn't, then we don't have to worry about anything else. So the way we figure out does y vary directly with x means if I take this x coordinate, what is happening to this x to get to y? And if we look at this first one, 1 is being multiplied by 3 in order to get to 3. 1 times 3 equals 3. Now that we have figured out what the first point is, we have to see if that applies to every single point on this graph. So if 1 times 3 equals 3, we have to say, what times 3 will get me to 9? 3. 3 times 3 is 9. 3 times 5 is 15. 7 times 3 is 21. So we know, yes, y does vary directly with x because all of these are being multiplied by 3 and still get the correct answer. So first off, this is yes. Second, it's asking, what is the constant? Since y varies directly with x, what is our constant? And our constant is what are we multiplying this x coordinate by, or this x column by, to get the y column, which in this case is 3, because we said 1 times 3 is 3, 3 times 3 is 9, 3 times 5 is 15, 7 times 3 is 21. So everything's being multiplied by 3. So k is going to equal 3. Then it's asking for the direct variation equation. So remember, the direct variation is y equals kx. So in order to write out this equation, we're simply going to, instead of k, we're going to put what we've already said the constant is. Remember, k represents the constant of the variation. So because k is 3, the equation for this direct variation is going to be y equals 3x. And that is how we solve example 1. Let's do a few more examples really quick. All right, example 2 gives us this list of different equations. And it first asks, which of the following are direct variations? Then it says, if it is a direct variation, what is the constant, or what is k? So let's look at letter A real quick. We have f of x equals 2.2x. Now remember, f of x is something we learned back when we started talking about relations and functions, and all f of x is just another representation of y, okay? So f of x, or y, equals 2.2x. And we're going to say, does this look similar to our direct variation form that we have earlier, which is y equals kx? Okay, it just has to look like this. It has to look similar. The variables can be a little bit different, but does it look similar to this? And in this case, for letter A, yes, this is a direct variation. Okay? And then it's asking, what is the k, or what is the constant, or what are we multiplying here? And whatever we're multiplying is what's going to be attached to the variable after the equal sign. So k, in this case, equals 2.2. Let's look at letter B. Y equals 4x minus 1. And it's asking, is this a direct variation? In this case, no, it is not a direct variation because we have this minus 1. Because we have this minus 1, this is not a direct variation. This is in slope-intercept form, but that's not what it's asking. Letter B is no. And since it's no, we don't have to find out what the constant is because 4 is not the constant here. 4 is the slope because this is in slope-intercept form. Let's look at letter C. D equals 45t. Is this a direct variation? Yes, this is going to be considered a direct variation. Even though this is a different letter and this is a different letter, variables can be interchanged with whichever letter you want. So that's not going to keep us from being a direct variation. This is still a variable equals a number times a different variable. And so yes, this is a direct variation. Now it's asking, what is the constant? And remember, the constant is whatever number is attached to the variable after the equal sign. So in this case, the constant is 45. Let's look at letter D. Now, letter D is a little bit tricky, okay? It kind of looks like the direct variation, but our direct variation, the number K, the number that's attached to the variable, has to be positive. So because this is -2, this is going to be no. This is not a direct variation because the number that's attached to the variable after the equal sign is a negative. Let's do another example. All right, example 4, it says graph the direct variation y equals 4x. Now we can still use the same steps that we use for the slope-intercept form because, like I stated earlier, a direct variation is just a different type and a different form of the slope-intercept form. So we're still going to make sure it's in the correct format, which it is, y equals 4x, or 4x plus nothing. Now we just have to identify our m and our b. Now our m is still going to be the number that is attached to the x. Even though in this lesson we're calling that number the constant, but it still can represent the slope as well. So in this case, our slope is whatever is attached to the x, which is 4. And we're going to turn that into a fraction, which is 4/1. And then now we have to find the b, which the b is the number that is left completely by itself, that's not attached to any variable. And if we look up here, we don't have a b, but we can add one in. We can say it's plus 0, because if I was to put plus 0 up there, it's not going to do anything different to my equation. Now, if I put plus 1 or plus 7 or plus any other number, it wouldn't work. But since 0 is not doing anything to our equation, we can put in plus 0. Now that I have that, I have a y-intercept of 0, meaning that my point is going to be 0, 0. Now let's go to the graph and graph this line. All right, now over here at my graph, remember, we're first going to start with the y-intercept, which in this case is 0, 0. So we're not moving up, down, left, or right anywhere. We're just plotting a point at the origin of 0, 0. Then looking at my slope, first I'm going to move up and down according to whatever my top number is. In this case, it's 4. So I'm going to move up 4 spots, 1, 2, 3, 4. And then according to my run, which is the bottom number, I'm going to move to the left or to the right. +1 means I'm moving to the right 1 spot, and I'm graphing that point. And then I'm going to connect the dots to create my line. And this is how we graph the direct variation y equals 4x. All right, example 4. Now, I know the last example was 4, but I messed up my number somewhere, so it's okay. This is actually example 4. Okay, last one was example 3. But example 4 says something like, find k if x and y vary directly when y equals 12 and x equals 1/2. And so what we're going to do first is we're first going to copy down what our direct variation form is, which is y equals kx. And then to solve any equation we have, we need to at least find 2 out of the 3 missing variables. So in this case, what information do I have that I can fill in? Well, I know that y equals 12, so instead of y, I'm going to put 12 equals, I don't know what k is because that's what I'm trying to find, is find k, times x. I do know what x equals, which is 1/2. Now that I've inserted these values, now I'm just going to solve the equation like I would solve any other type of equation. Okay, and the first thing I'm going to do is I'm going to move this around a little bit so it's a little bit easier to read. This is saying that this is 1/2 times k equals 12. Okay, now in order to solve for k, I have to do the opposite of what's happening to it. It's being multiplied by Well, k is being multiplied by 1/2, so I need to divide 1/2 to each side in order to get rid of it. This means my 1/2s cancel out on this side, leaving me with k. And remember, we have a special rule when we're dividing fractions. This is keep it, so we're gonna keep the 12, we're gonna turn it into a fraction. Keep it, 12 over 1, change it to multiplication, and flip it to 2 over 1. We're gonna solve this out. 12 times 2 is 24 over 1. 24 over 1 can be reduced down to just 24, meaning k equals 24. It also wanted us to write out the equation for the direct variation. So we're gonna do that right up here. So instead of using k, we're gonna use 24. So the the constant is 24. The direct variation is y equals 24x. So our two answers for example 4 are k equals 24 and y equals 24 times x. Let's do one more example kind of like this one, and then you can get started on your lesson. All right, example 5 is a little bit more complex. It says, if y varies directly with x, and that's just telling us, hey, this is going to be a direct variation problem, and y equals 6 when x equals 2, find y when x equals 2 over 3. So in order to do this second part, which is find y when x equals 2 over 3, we first have to find out what the constant is. In order to find out what y is when x is 2 over 3, we have to have something we can multiply this 2 over 3 by. And that would be our constant, because remember, our direct variation is y equals kx. So in order to find the constant, we have to use this information right up here before we can worry about the second part. So first we have to find the constant by saying when y equals 6, x equals 2. So we have to use this information to plug into our equation down here. When y equals 6 equals k times x equals 2. So now I need to use this information to find out what k equals. And I'm going to do that by doing the opposite, just like I would do with any other equation. I have to ask myself, what is happening to k? K is being multiplied by 2, so I have to divide by 2 in order to figure out what it is. So I need to divide 2 to both sides. Meaning k equals 6 divided by 2 would be 3. Our constant of the variation is 3. Now that I have this piece of information, I can find y when x is 2 over 3. So again, I'm going to copy down y equals kx, but in this case I don't know what y equals because we're wanting to find the new one. So I don't know what y equals our constant, or our k, is going to be 3 times our x, which is 2 over 3. Now that I have this piece of information, I can multiply to figure out what my y equals. So this is going to be y equals 3 over 1 times 2 over 3. And remember, our multiplying fractions rule is we just multiply the top and then multiply the bottom. I do not need to have the same denominator. So this is going to equal 3 times 2 is 6. 1 times 3 is 3. Then I divide that out, or I reduce my fraction, and I'm going to get y equals 2. I found y. So my two answers are going to be the constant is k equals 3, and then y equals 2. All right, that's going to wrap up today's lesson. I hope you fully understood all the examples and the new concepts we went over. If you don't, I fully understand. Please feel free to reach out to me with any questions, comments, concerns that you might have over today's lessons, or any specific number in the assignment that we're doing. If the best way to reach out to me is through either calling me or texting me. If you don't have my cell phone number already, your parents should have it in the email that I sent them. I wish you the best luck in this lesson, and I will see you next time.